go. Yeah, so welcome again, everyone. And here we are at Crafting Publication Quality Data Visualizations with ggplot2. Based on your introductions, it sounds like you're all in the right place. And can you guys all see my screen, the slides?
Yeah.
Okay, good.
Or I can see it.
Yes,
hopefully everyone can.
So today we're going to talk about customizing color palettes, in particular with accessibility in mind, customizing legends a little bit, customizing axes, how they look. I actually took this out about date axes, but if somebody's really interested in plotting time series stuff, let me know and we can do a little bit of that. Customizing the appearance of plots with themes. I know that's something probably a lot of people want to do. Arranging multi-panel figures. This is something that was, for me at least, really helpful. It was the thing that took me that last step from making my plots in R and then exporting them into like PowerPoint and like arranging them and then having to like export that, and it was pain in the butt, to being able to make the whole thing in R. So hopefully that will be helpful for some folks. And then finally, how to save those figures in the right format, right dimensions, whatever your journal author guidelines require. And yes, Ejin, I know you're interested in time series data, so I'll try to do that if we have some time to do some interactive stuff, or at least point out where to go for help. So please interrupt me at any point during this, and ask questions and things like that. Yeah. So today, these are the packages that we're going to use. So tidyverse, really probably mostly all we need in that is ggplot2. And I think some of the code uses some functions from the dplyr package. But you can go ahead and just load library tidyverse. Palmer Penguins is the package that we're going to use for the data. The patchwork package we're going to use for arranging multi-panel figures. And then color space, actually this one you don't need to install. I'm just going to like demonstrate some of this stuff from the color space package, but we'll look at that later. Yeah, take a moment. If you I forgot, I'm going to share the slides with you guys in the chat. 1 second here. Put that in the chat. So this is the link to the slides. So if you open that up in a web browser, you can actually click on the little copy button and you can copy and paste things into R, and you can run that code. If it doesn't run for some reason, probably means you need to install one of those packages, one or more of them. I know there's like a lot of windows. You've got a Zoom window, you've got maybe the slides open somewhere so you can copy and paste code. So just, at any point, let me know if I'm going too fast or you want me to go back or something like that. I have an R script open, and so I'm going to go ahead and just paste those in now to so that we can kind of like have a little script going as we go along. And yeah, you can ask questions in the chat too. Christina is going to help out and will interrupt me if I need to be interrupted. So let's see, faces over there. Cool. So journal requirements. Journals often, so this is all about publication quality graphics, data visualizations, right? And so a lot of times what that means is there are certain requirements from whatever journal you're submitting a manuscript to or hoping to submit one to. And so what are some of those requirements that you've run into or expect to run into? Font size, we see, yeah, I see font size in the chat. We'll talk about that today. Oftentimes, yeah, colorblind friendly palettes. Yeah, that's, I think, a really good thing to do. I've actually personally never seen a journal require it. I would love if they did more often, but yep. I find like oftentimes they require a certain resolution. Yeah, high quality images, readability. Yep, black and white sometimes is important, or at least that color figures are also readable in black and white. They might like charge you extra for color printing fee, which is a silly thing, but yeah. Yeah, so that's a good list there. So here's my list that I put down.
So,
high resolution. Oh,
Val has something about annotation. I'm not sure I know what that means exactly
oh yeah,
in
I
this
didn't see
context.
that.
Oh, I just meant that sometimes they require you to say, I don't know, add an asterisk if something is significant, or like little bars or some additional stuff that isn't necessarily in your data, but it's more like the interpretation that you provide with the data.
Yep.
Oh yeah, definitely. Awesome.
Yeah.
Yes.
We're not going to talk about annotation today, but it is something like that specific problem of like indicating statistical significance that is a possibility for something we'll include in the next workshop, the extensions to ggplot2. And it's definitely something we can help you with if you need help with that. So yeah, high resolution, this is my list, high resolution, specific file types, figure size limits. Sometimes they will tell you, oftentimes they won't tell you what size the final figures should be, and they'll just kind of like maybe mangle them a little bit. But sometimes they'll tell you what size they should be. Yeah, multiple panels, a certain way those panels are labeled, like they want a lowercase letters with a parentheses at the end, or maybe they want an uppercase letter with a period, or right, they might have very specific requirements there. Font size requirements or suggestions. And then there's a whole list of other things that are not usually required, but I think are good practice. We already mentioned accessible color palettes, grayscale friendly color palettes, like that still, you can still understand the figure if you print it out in black and white, right? This one, perceptually even colors, is one that nobody mentioned, but this is the idea that there's not one color that stands out more than the others in your color palette, and therefore would draw the reader's attention to those data points more. And also the sort of even part of it is also like in a color gradient. Let's say you have a color gradient that goes from red to pink to white. Well, you want the difference between the midpoint, the pink, and the red to be like visually as different as the pink to the white, if it is to represent equal like steps in your data, right? So that's perceptually even. So that's something to aim for. Screen reader compatible. So this is another thing that has to do with accessibility. High data ink ratio. This is this idea that basically like you should simplify your plot within reason so that the important stuff is not drowned out by a bunch of like extras. And so that is something we can do a lot with adjusting the theme and things like getting rid of grid lines if they're not needed, or maybe changing the background color of the plot. And then, yeah, arranging the plots into multi-panel figures. So we're going to work with 3 example plots today, and today's focus is not on building the layers of the ggplots. So I'm just going to very briefly describe what's going on in the code here, and then we can copy and paste that into our script. So this is using the Palmer Penguins data set. The penguins is the data here. And this is the little bit of dplayer code here. We are filtering that data set in this plot to remove missing values for sex. This is, if you were in last Monday's workshop, this is kind of a variation on what Jessica made for that workshop. So this is the data, and then the aesthetic mappings here, AES. The species is mapped to the x-axis, body mass is mapped to the y-axis, and the shape of the points is mapped to sex. So here it's automatically assigned, circles for female, triangles for male. We're using geom_point to represent these individual data points in the background here. Alpha equals 0.2 makes them slightly transparent. Position jitter dodge makes them all kind of scattered and separated by sex. And then this stat summary layer is what is drawing this point and error bars that in this case represent the mean and standard deviation. And so that's our plot 1. And then Plot 2 is using the penguins data set again. We've got these aesthetic mappings, flipper length on the X, bill length on the Y, species is mapped to color. Fill is also mapped to species. So species is both color, fill, and shape, actually. And that makes the points, the lines, different colors. That's the color. Fill is actually what controls this ribbon here in the geom smooth. And so we need to do that. And then there's also different shapes, circles, squares, and triangles. And then we have geom point layer, and the geom smooth layer is these best fit lines that are using LM. So just linear models, straight lines. So that's P2. And then our third plot is basically identical, except we have bill depth on the y-axis instead of bill length. So those are the three plots we're starting with, and we're going to modify. And so I'm just going to right now make this a little bigger, and then I'm going to run all my code and just make sure it all runs, works. No complaints from R.
What is that? Those gray boxes popping up showing what you're typing.
Oh yeah,
You can see those, right?
Yes, this is I have this on just so you guys can see when I'm using keyboard shortcuts, because sometimes I forget to explicitly say what I'm typing. So Command Enter is, the shortcut on a Mac for running a line of code. So I've run all that code, it works. So those are our example plots. Anybody need another moment with those or have questions before we customize some colors? Feel free to interrupt if you do. And now we're going to talk about customizing colors, which is really fun. So choosing a color palette, it is a good idea. So it is a strong temptation to choose a color palette based on what looks nice. And I think that is fine for certain applications, but when you're making a publication quality figure, that probably shouldn't be your first priority. It's a good idea to choose a palette that is colorblind friendly, and by that I mean that so people with different forms of color blindness can still tell the different colors in your palette apart. Is important. Grayscale friendly. Also important, for people that might want to print your paper out on a grayscale laser printer or read them on kind of an e-ink reader or something like that. It'd be nice if they could still tell the difference between the colors and this perceptual evenness that we talked about. And also high contrast, both between your data points in the background and also maybe between data points, especially for categorical data. So there is a built-in set of color palettes in ggplot2 that ticks almost all of these boxes, and it's called Viridis. And so this is a really good first choice. It's maybe not the prettiest, it's maybe not exactly the colors you want. You might want to change it for some reasons, but it does tick all those boxes. So we can do those by adding a scale function to our plot. So this is actually not one of those three plots we made because I wanted to start my demonstration with something that actually has a color gradient. Those other plots we made just had color for species, so there were just three colors. Viridis is a lot easier to see what's going on in a color gradient. So here we're making this plot that I've called V that has body mass mapped to color. So we have a continuous variable there. With the default colors, it looks like this on the left. It's just a single hue, I guess it's called. Is that right? Single whatever, going through from dark to light. And then on the right, we have the Viridis color palette that goes from kind of a purple to a yellow at the end. The top end of the scale is this it's kind of hiding back here, but it's this really bright yellow. And we'll kind of deal with that later because that really bright yellow does not look great on white backgrounds. So there are actually a family of palettes available with this, scale color Viridis function here. And you can adjust them with, sorry, giving you guys motion sickness, with the option argument here to get these different colors. And all of these tick most of those boxes of colorblind friendly, grayscale friendly, perceptually even. So this is a really nice place to start. Yeah, so let's actually, I'll just go over to R real quick and I'll just show you if I start typing scale color, you see that there's lots of scale colors available. If I keep typing Viridis, we see that even within Viridis, there's 3 different ones, B, C, and D. D stands for discrete, C stands for continuous, and B is for binned. And so depending on what kind of data you have, you would pick the kind of correct one. So discrete is for like categorical data, continuous is for continuous, and we'll see what binned does, I think, a little bit later. So those are our options there. We can look at the help file for them. And they're all on the same help page. And this is also where you can see what the different options are here. So there's Magma, Inferno, Plasma, Viridis, Civitas, Rocket, Mako, and Turbo that you can play with. Now, I mentioned that really bright yellow is pretty hard to see, especially on a projector or something. Like if you're giving a talk, you don't want to use a yellow that bright. And you can adjust the kind of range of colors within those palettes that are used with the begin and end arguments. So here I'm saying, you know, start 10% away, 10% into the purples and end, you know, 90% through the color palette. And so on the right, we get something that's a little bit easier to see. There, we don't have that really bright yellow at the end. And so that's kind of an easy way to tweak this Viridis palette to make it something that is going to look nicer in a publication quality figure or in like a talk. Now we have discrete data in our example plot. And so we can add this with the scale color Viridis _D. And I'm going to use option C and end at 0.9, 90% of the way there. So if we do this, if we add this to our P2, for example, this is not quite right because we've got the lines and the points following this new color palette, but these ribbons are not, and they're not matching. So how do we fix that? Well, we could, there's a couple ways we could do it. So I'll copy this over so I can show you guys. So, yep, this is not right. Another way we could do this, or one way we could fix this, is we could add with a plus there another scale, and this time do scale fill Viridis _D, and then type exactly the same stuff. So it matches the previous one. And then any scales that are identical get combined automatically by ggplot2. So this works, but we have to type all these arguments again, and we might make a typo, and then like I don't think it'll get combined if we do that. Oh, it does. Who knows what happens if you do that? You know, if we do that, then it's, oh, there's weird stuff going on. So another way to do this is there's an aesthetics argument. If I hit tab, I can see aesthetics, and then we can say fill and color. So we just make a little vector there. And now this scale is going to be applied both to the fill and to the color aesthetics. So fill again was these ribbons, and color is the points. Fill is for other stuff too. Like if you use a point that has a border, then fill is actually what the inside of the point is. So this is pretty useful little trick. Okay. So that's one set of color palettes. There are reasons you might not want to use those. For example, it doesn't include a diverging color palette that, you know, that would be probably something common with like RNA-seq or gene expression analysis, where you want to have, you know, your 0 be white and positive numbers be blue and negative numbers be red or whatever like that. So there are a lot of ways to get additional color palettes in R. There are so many to explore. One that I really like is this color space package. And we're not actually going to use the package. We're just going to use the palette creator thing on the website here. You can also do this in R. I'll just want to show you what it looks like a little bit because it's very cool. It's kind of over the top, but you can choose different color palettes in here. So we want, a qualitative color palette here. We can choose from a drop-down menu of different palettes. And then what we can do is choose what we want our example to look like. So we're making a scatter plot maybe, so we'll choose scatter. And then we can test out what it looks like, for example, in black and white. Yeah, this is not black and white friendly, this palette, right? All the colors look the same, black and white. And we can test different kinds of color blindness. So for a person with this Dutton type of color blindness, these two colors look pretty identical. With this Proton type of color blindness, these three colors look pretty much identical. And for this Triton type of color blindness, well, probably this one and this one look pretty darn close. So this color palette, not particularly colorblind friendly, and we can go through different palettes and kind of test these out. And then when we were ready to use them, there's a variety of different ways we can get them. We can see in this R tab, it actually gives us some R code and some information on how to do that. But we can also just get these hex colors. And these are representations of colors, and we can just kind of copy and paste these or download these. And I'll show you how we can use them in R directly in a little bit. I also want to show off this calls for all package. This is very cool, I think. Calls number 4, all. And if we load that, there's a package call, or there's a function called calls for all. What's it called? C4A _ GUI. And if we run that, you guys can just watch me. You don't have to run it right now. I'll just show you kind of what it does. It is similar. It has all these color palettes. We can change some sliders and things. So for example, we're looking for a palette. We only need 3 colors for the 3 species. We want it to be categorical. And we can go through this table that it creates with all this information about these palettes. It's taking a while to update here just because every time I move the slider, it has to update it. So now it's just showing the first 3 colors in the palette. And we can go through and we can see, so this palette called Accent, is it colorblind friendly? If I mouse over this, I know this is probably very small for you, but it says, be careful, some colors are hard to distinguish by colorblind people. Vividness. Here it tells me these are pastel colors, which are good for space filling visualizations like maps. Fair. Colors are equally vivid and bright. So that's good. Low contrast. So there's a warning here about contrast. So we can go through here and we can look for a palette that is, colorblind friendly, and we probably want something that's vivid and fair, maybe. And we could, find the colors that we want. And then when we want to use them, we can copy those colors into, I think that just copies it onto our clipboard. Nope, didn't. Copy into R. Not exactly sure what that does, but we can highlight these and they have the hex codes. They're actually in there. They're just the same color as the boxes. So I can highlight those, for example, if I wanted to get that and then use it in R, I can paste those in and we can do some stuff with them. Wesley asked, how did you open this file? I missed it and can't figure out in the GitHub link. Yeah, if you load the package calls for all, and then you run this function called C4A _ GUI, it launches what's called a Shiny app that's running in R. Yeah, that's where this is. You might have to install additional packages to do that. So that's why I was saying you don't need to worry about running it right now, but you can kind of save it as something to check out afterwards. If you did run it, note that you do have to close it before you can use R again, because it ties up, Shiny apps kind of tie up R. So we can get colors that way, and we can use those colors in kind of a manual color palette. So there are so many different ways to get color palettes in R, custom color palettes. I'm going to show you now how to do it kind of manually, because this is probably the most universally useful. So here are some colors that I have picked out for our color palette. And if you have a recent version of RStudio, it will actually color them for you so you can see what they look like. I can't remember which of the color palettes this is, but this is one that I found through that Calls for All package. So they are colorblind friendly, I believe, and perceptually even. So we can just make a vector here called whatever, my cols, with our colors, and then we can use Scale Color Manual to use them. Oops, I have to run this code first and then run Scale Color Manual. So we're providing the colors to the values argument, and we're using that aesthetics again to say, apply this both to the color and fill. It's always a little tricky for me to remember which argument you actually give the colors to. But if we look at the help file for Scale Color Manual, we see here it's ... and then values. So in this case, it's not that hard to figure out. Yeah, it's the values that we're giving it. Breaks is like how many breaks there are, which doesn't really apply to a color palette like this. So we ignore that. Yeah, so you can use any colors you want as long as you can find those hex codes. And there's tons of color palette generators that have nothing to do with R as well on the web. And that allows you to use those. As long as you can get those hex codes, you can copy and paste them and create your own custom color palettes. So if we want to specify which colors go with which penguin species, we can use a named vector instead. So here I've created a name vector by just saying on the left, whatever the species name is equals, and then the color. And so that will produce something like this instead. So at this point, I'm going to go with these colors, and now so that's why I'm assigning these now to the plots. So that is actually the code that we're using. This was kind of me playing around, I guess. Delete that, paste this in. So this way, if you really want to be specific and you say, no, I don't want it to just do it in whatever order, you can specify which colors go with which levels of your factor. So now we've got P2, looks like that, for example. Okay, before we move on, other questions about color palettes?
I just think what you showed, the custom color palettes, is so cool. I really like that.
Yeah, there's lots of like packages for ggplot2 that give you other variations on scale _ color _, but this is always going to be the most flexible because all you really need to know is what the colors are. I'll also point out just briefly that there doesn't make sense for this plot, but that other one I showed with the continuous color, there is a scale color gradient where you give it a beginning and an end color, and it fills in the middle for you. And so that's useful for making a custom color bar, like where there's a gradient for a continuous variable, which is kind of the equivalent of this scale color manual, but for continuous variables.
I actually have another question, but it's more like a general question.
Yeah.
So whenever you're making a plot, do you recommend to like you're setting these plots to like P2 and P3, do you recommend to like set to a variable and then update that variable like you're doing P3 plus and then a new line? Do you recommend that's probably the better way to, like, if you're updating a plot a lot? Do you think that's the better way to do it?
It's not usually how I do it. I'm doing it this way mostly for the slides, and so that we're not having to worry about all this code. We don't have to think about this. And so you might find it useful for the same reason. You're like, okay, I made the plot, I did all the layers and stuff. Now I want to focus on customizing it. So, I'll have all this stuff in a separate part of the script, and then later on I'll go and modify the appearance or whatever. But there's no rule for it. I would say pick better names than P1, P2, and P3. These are I'm not going to remember this. You know, I'm not going to remember, oh, which one's P2, which one's P3, right? They should be called something like, you know, bill length plot and bill depth plot, something like that. But again, for like succinctness of showing on slides, I chose P1, P2, and P3.
Yeah, I mean, so usually when I'm making plots in ggplot, I end up having like all of my lines of code for each plot, like in one giant chunk, and then just assigned to one name.
And at the very end of these slides, we'll also give you like the whole thing, the code, so you can just copy and paste the whole thing we make today. Okay, I'm going to talk about legends real quick, and then we'll have time to take a little break and get water and stuff. So legends, another thing that we often want to customize. There are, just like everything with ggplot2, there are multiple ways to change things. But if we want to change the name of the scale, the name of the legend, for example, we can do that with labs, which is short for labels. You've probably used this to like maybe change your axis labels. Well, you can use it to change the labels for a color scale as well. So this example, I'm taking P2 and I'm changing the name of the color scale to penguin species. Now, this has done this kind of like undesirable thing again, where now there's two legends. There's one that just has color in it, and then there's one that has the shape and the fill in it. So we need to actually give names to all of those scales to get them to be recombined. So we have to do something like this. We have to say color is penguin species, shape is penguin species, and fill is also labeled penguin species. And then ggplot will do the smart thing and combine them all into a single legend. So as long as they are showing, as long as they're mapped to the same data and they have identical names, ggplot will combine them into the same legend. So if you're having trouble with like multiple legends showing up and you really want them to be combined, it's either that those legends aren't corresponding to the same data for some reason, or you haven't named them exactly the same thing in your labels. So we'll save this. This is another pattern you'll see a lot with ggplot2. I'm putting parentheses around this whole thing, and that allows me to both assign it to P2 to like overwrite it, but it'll also plot it out, print it out for you. That's all that is. So I'm going to go ahead and do that for P2. Boom. So now we've got a label there, and also for P3. Those have the same legend, which we're going to combine once again later on when we do multi-panel figures. Now, what if instead of Adeli, Chinstrap, and Gentoo, we want to use the Latin names, for example, for these penguins? We could go back and change it in the data. And in fact, very often that's the easiest thing to do, the best thing to do. But I did want to show you how you would change it in ggplot, in the legend itself. So we're going to use, again, a named vector. So that's what's being created here. So Adeli equals P Adeliae, Chinstrap is P Antarcticus, and Gentoo is P Papua. So this named vector is going to be used multiple times. So that's why it's created separately like that. So I'll just copy that over. And I don't know, for those of you that aren't maybe super familiar with what a named vector is, I'll just print that to show you what it looks like. So it's a character vector, but there's these names on top. They're kind of like row names for a data set. They're not really, part of the data, but they're there, and they're used in ggplot2 to like, match things, match things up. So we can give that in scale color manual to the labels argument here. And that is going to change the way that the legend looks. And we can also do it with scale shape. So we have to do it for both scale color and scale shape, so that they all get combined. And I can show you why here. We'll copy this over. So if we, for example, let's get rid of that and let's just get rid of that for now. And what is this going to do? It's going to do this thing again where we've got two legends now. Okay, so we need to do aesthetics equals color and fill. And then we do this. And oh, there's still two legends because there's one for shape, right? So we need to add our scale shape discrete labels equals sign names. The nice thing about ggplot is that once you learn kind of one thing, you can apply that to other situations. So scale color manual, scale shape discrete, they both have the labels argument. How did I know they have the labels argument? That is a very good question, actually. Scale color manual. If we look that up again, labels is not in the list of arguments here, right? So how did I know that I could use labels? Well, it's all about these dots. And so this is a good place as any to discuss what dots are. When you see dots in a help file like that, usually means that they're arguments that belong to some other function. They'll get passed to that function. So if we look down here, it tells us, yeah, the dots, arguments passed on to discrete scale. So that means that any of the arguments that discrete scale takes, scale color manual also takes. So that includes labels, limits, expand, all of these things. And so that's how I knew that I could provide labels. So this is one of the tricky things about ggplot2 is that the help files are pretty densely packed with information, and it takes a little bit of an extra work to kind of figure out how to do everything with them. So when you see those dots, again, it's worth reading what they do, and then you can click on whatever that function they're passed to, and then you can read more about how they work here. So in labels here, it tells us I can give it a character vector, which is what I've done. I could also give it a function or some other stuff, but we're going to just do the simple thing and give it these actual literal values. Okay, so now we've got a plot that looks like this. And we can do the same thing for P3. Paste that in. So this one, we're also just using that same sign names vector, named vector. And so we get the same scientific names. And this is just reminding me to tell you again, this case probably would have been easier just to change it in the data because we're using it in multiple plots, but this is fine. It's good to know how to do this. Okay, and so now we can apply what we learned to actually modify P1 too, to capitalize the words in the legend. Right. And so again, this is a situation where we've learned how to do this once with color, and now we're doing it over here with this legend. So before, when we changed the names from the common names to the scientific names, we used the scale color manual function. What scale function are we going to use for changing this legend?
Isn't it the points?
Yeah, it's whether they're circles or triangles, right? It's the different shapes. So we have in ggplot2, just like we had a scale color, we have scale shape. So there's going to be a scale shape that we're going to use. So P1 plus scale shape, and we can use the autocomplete to kind of figure out, oh, it's discrete. Right, we could do manual if we wanted to specify which shape goes with which sex, but for now, we'll let it do kind of the automatic thing. But we have discrete data, so we're going to use that, and then which argument changed the legend title. Oh, actually, we didn't do that before. We did it with labs, but we can also change. I'll show you. You can change the legend title here with name. So name equals, I'm going to change that to capital S sex, and that changes it there. So there's multiple ways to do things. We could have instead done labs shape equals sex. That does the same thing. So either way. And then for changing the argument labels, we use again labels, same as with color. So once you've learned how to do it with color, now you know how to do it for shapes. So labels equals, instead of lowercase female, we want that to be uppercase female. And instead of lowercase male, we want, equals uppercase male. Ta-da! So now we have our nice like capitalized legend for P1. And so here's another way to do it. Oh, actually, in this case, I just use scale underscore shape. And I forgot about that. So we don't even need this discrete here. I'm gonna save those changes by assigning it to P1, overwriting it. So axes are also a type of scale. So the really good news is everything you just learned about scale color and scale shape really applies also to scale X and scale Y. So scale X in this plot is discrete. So if we wanted to modify the scale or modify the axes, we would use scale X discrete because we have discrete data. And the y-axis, if we wanted to modify that, we would use scale Y continuous because we have continuous data on the y-axis. And we can use everything we learned to modify the names of the axes, and what shows up on these labels as well. So for example, if we want to, again, use those scientific names, it's really the same thing as when we changed the color scale. We're changing scale X discrete to have the labels psi names. So this is exactly the same thing we did for color. Now we're doing it to the X axis. So again, the nice thing about ggplot2 is it is designed around a grammar. If you didn't go to last Monday's workshop, the GG in ggplot2 stands for the grammar of graphics. And so the nice thing about that is that once you learn how to do something once, it's easier to apply to new situations and kind of use the intuition you've developed to kind of just try things out a little bit, or at least like search for help more easily, hopefully. So we can do that. We can customize our axis now to now have the scientific names down here instead of the common names so that it's all consistent for our 3 plots. We can also just change the axis titles. Again, with the labs argument, we can do that. I'm guessing that many of you have done this before. It's a thing we often want to do. Our variable names are usually not the sorts of things we want to actually label our X and Y axes. They're not very human readable. So here we just got more human readable versions. Custom breaks. So breaks are where these tick marks are placed, basically. That is a thing that people want to customize very often. You can do it with this n.breaks argument here. Now, notice that in this plot, there are not exactly 12 breaks. There's 1, 2, 3, 4, 5, 6, 7. So actually not even close to 12. And that's because this argument, it preferences having breaks that are pretty, right? So whole round numbers. If you wanted exactly 12 breaks, you could supply them using the breaks argument. So this is n.breaks. Breaks, you have to give it a vector of exactly the numbers that you want those tick marks to be at. They don't have to be evenly spread out. You could do something weird like this. That works. But you do have to like tell it exactly where you want the breaks to be. So the breaks argument is where these tick marks are. And so this is why I mentioned for the color doesn't really make sense. When we were talking about continuous color palette, you can supply breaks there and it will show up on that color bar where the numbers are, how many tick marks there are on that color bar. So it does the same kind of thing everywhere. But we don't want that. We're going to do this n breaks thing here, change the number of breaks to around 12. So yeah. And then, oh, I did want to briefly show, somebody asked about date scales. So there is a scale X or Y date, and there's also a date time one. And so these work when your data is dates or date times. It has to be that type. It can't just be a character that looks like a date. It has to be an actual date or time. But it allows you to do some really nice things. This is just an example that I copied from the help file. So that's the base plot, and we can do base plus scale X date. And we can do things like date underscore breaks equals 1 week. And that it'll put a tick mark every week. Or we could do it every 2 weeks. And it'll put a tick mark every 2 weeks. Or we could do every, 4 days. And it'll put a tick mark every 4 days. And we can also do date labels. This is a little bit weirder. The labels are this weird format here, but if we look date labels, it tells us there are some codes defined in the help file for strf time. So this is a long help file, but day of the month as a decimal number is percent lowercase d, and last 2 digits of the week is percent G, whatever. Like this is not going to make any sense, but I'm just demonstrating here. You can have it do whatever you want in terms of the labels. So if you're working with dates or date times, these scales are really nice, and you don't have to like fiddle with manual breaks and manual labels so much. Okay, let's move on to themes, talk about themes. So there are complete themes in ggplot2 that you've likely encountered, or maybe not, but we have these themes that all start with theme underscore something. I really like theme underscore BW. That's this one, makes it look like this. So instead of the gray background, it's white. It's got a border around the thing. It's got the grid lines, whatever. There's also theme minimal, which is similar, but it doesn't have the border around it, and it doesn't have tick marks. It just has these grid lines. There's quite a few. And there's also packages like the GG themes package and a bunch of others that give you more of these completed themes. If you're happy with one of these completed themes, by the way, this is also an easy way to change the font size and the font family. So for example, if I wanted my access labels to be in Times New Roman, font size 9 to make them less readable, really tiny font and Times New Roman, I could do that. And that's what I'm showing right here. So if the journal you're hoping to submit this plot to does have a font family requirement or suggestion, font size requirement, you can do that in here. You can do that with theme BW, theme minimal, whatever you're working with. And if that's all the customization you need, easy, done, right? But very often we want to customize other things about our plots. So how do we do that? So customizing things about the appearance of your plot involves knowing the name of the theme element and its corresponding element function. So how do we do that? We're gonna talk about that in a bit, but here's an example. So axis.title is the element that controls the axis titles. So it's not that hard to figure out, but yeah. And then because that's text, it goes with element underscore text. And that function is where we can change things like the font face, whether it's bold or italics, for example, the color, size, all sorts of stuff. And all of this goes inside the theme function. And we can take advantage of the autocorrect or the autocomplete stuff quite a bit. So let's see, this was P1. So we do P1 plus theme parentheses, and we see if we hit tab, then you can see everything you can do. So these are all the theme elements here. And you can see that they're kind of hierarchical in the way that they're named. So for example, title, all title elements, plot, axes, legends, that affects everything that's a title. Axis title, that affects the labels of axes. So in this case, it would be like price and date, those words. Axis title.x, that only affects the labels of x-axes. And then if you had two axes, label or axis.title.x.bottom only affects the bottom one. So you can find a lot of stuff just by kind of typing theme and hitting tab and like scrolling through this, or typing the first few words. You're like, okay, it has something to do with an axis. Is it the line? Is it, the ticks that I'm looking for to modify? And then when you hover over these, it usually recommends or tells you what the corresponding element function is. So in this case, for the axis ticks, because they're little lines, you have to give it element line. So for example, if we want to do that and we typed element line, again, we can hit tab and we can see all the stuff we can change. So we can change the color, line width, line type, line end can be either round, butt, or square. Color, you could put an arrow at the end of your check mark. That would look silly, but you could do that. Size, yeah. So that's kind of how we do that. Everything that you have to figure out the element, figure out what element function goes with it, and then figure out what you want to change about it and how to do that. So it's kind of a lot, but a good way to start is like find one of these complete themes that's close enough that gets you most of the way there, and then you can add on to that and modify that even further. So in this example here, I've decided to start with theme minimal, which if you remember back here, doesn't have a border around it, but I like the appearance of the grid lines. I like that it doesn't have tick marks. Other stuff about it is nice. So we'll start there. We'll make the base font size 10, and then we'll add some axis lines. So axis line equals element line, line width, and a line end is just like how these affects how these lines meet up in the corner, for example. So right now, I want to do some audience participation to kind of demo how to figure this stuff out. So name something about our plot here, P1, that you would like me to figure out how to change, and I will figure it out. We'll do it together. What's something we might want to change?
Maybe making not only the female male dots different, but make them different colors, like red and blue or something.
We can do that. That we would do actually, because that has to do with the layer that's actually representing the data. We would do that with a earlier on in the plot. So I'll just scroll back up here. So here we've mapped the X to species, shape to sex. We would have to add color equals sex also. And then we could add, we could do a scale shape manual and a scale color manual like we did before. So we could do that. I want to, for right now and for the reasons of just time, let's focus on something that's like not about the points. I don't know if there's a better way I can describe it, but something that's not about the points or the legend, but just more like appearance modifying. Val says, can the legend be at the bottom? We can do that. There are several ways to do that, of course. But if we hit tab again here, this is actually an easy one and probably a very common one that people want to do. There is a legend dot position argument. So okay, so we got the legend at the bottom. Removing the gray grid was another suggestion. So let's figure out what that's called. So a good way to do that, if you go to the website version of the help files we were just looking at. So this is the ggplot2, their website. If you Google ggplot2 tidyverse or something like that, you can probably find this. And in the reference here, this is all the functions in ggplot2. Go to themes, go to theme, and you see everything, but you also see examples. And so that is really a nice way to kind of like, if you're stumped, you can scroll through these examples and be like, oh, weird. If I wanted to make this border green, now I know how to do that. That's called plot background. So that's not actually the thing we're looking for, right? You might have thought, hey, this is plot background. Nope, it's panel background. So we can use panel background to do some stuff, and that looks like it corresponds to element_rect. So panel.background element rect. Can we say fill equals white, maybe? Ah, very nice. Now our grid lines were white, and so they've disappeared. So if we want those grid lines back, we can do the same kind of thing. We can look back here and we can figure out what the grid lines are called. So it looks like we've got panel.grid.major, panel.grid.minor. So panel.grid probably does both of them. I'm guessing it's element line. And I'm guessing we can just say color equals gray. Or we could use a hex code or something like that to do a specific gray. But yeah, that brings our grid lines back, for example. And it looks like by default, the minor grid lines are a little bit thinner than the major ones. So if we wanted to get really specific, we could do that. Can the x-axis label be placed vertically? Oh, yes. Yeah, I think I know what you're talking about. So this where it says P Adelie and P Antarcticus, can we turn those at an angle or something? So that would be another thing. We could scroll through here and kind of see what it is, or let's take the type a few letters and guess approach. So it's not axis title. Is it axis text? It's not axis ticks, I don't think, because those are lines. So I think it's going to be axis text. And we only want to do it to the x-axis. And I'm guessing this is element text because it's axis text. And then, yeah, this has in it, this is actually a tricky one to do. Angle, 45 would be like that. And I guess 90 would be straight up and down. So that's not bad. So yeah, we can do that. I like 45, but then we've got this weird thing where the tick mark is in the middle of the word. And so this is, I don't know, I never remember which one of these, horizontal justification or vertical justification. I feel like maybe horizontal. This is like just a thing. This doesn't make sense to me in my brain. I just have memorized this. So I hate to say it, but there are certain things about ggplot2 that are like still a little bit of a mystery. But we can, maybe we can see if there's an explanation about it here now. What did I do? Angle. See if there's anything on the help page here. They did this with the axis title. They changed the angle. Yeah, they don't have an example of tilting the labels, but that is how you do it. I can't remember how I learned this HJust thing horizontally. Yeah, so I think basically, I think it's in the middle. HJust equals, what's -1 do? Yeah, I don't know. Sorry, I hate to say it, but this is one of the things that I have just memorized. Angle is 45, HJust equals 1 is how you get the labels to look like that. Wesley put in the chat a nice cheat sheet, looks like. So that's great. And yeah, I just wanted to demonstrate the process of figuring out how to do these things. And some of it takes additional Googling, like that changing the angle here, that might have taken additional Googling besides just looking at the help page. But there is a lot of stuff in this help page, a lot of examples. And so that's a good place to start. Scroll through these examples, go, oh yeah, that's the thing I'm trying to do basically, or that's the element that I'm trying to change, but I want mine to be red instead of white. And then you can modify some code from there. Oh yeah, back to slides. So any other questions about that, about like how to figure out how to change the themes?
Wesley shared a nice cheat sheet. You
Yeah, I saw that.
saw that, right? Sorry. Okay.
That is excellent. Yeah, thank you
Yeah,
again for
love
that.
it.
Yeah, it's good to have these kinds of resources. So one really useful thing that you can do with these themes is once you've created it, you don't have to type this whole thing for every plot. So let's say this is our theme that we wanted to use here. Rather than going P1 plus all this stuff and then P2 plus, all this stuff, copy paste. We don't have to do that. We can create an object, an R object that's called, my theme, for example, and we can paste all that code there into it. So now we've created something called my theme. So this, you can see, exists right here in the environment. And now we can just do P1 plus my theme. Oops, I have to spell it right. And we can do P2 plus my theme, right? We can also use a function in ggplot2 called theme underscore set. So you can just put this at the top of your script. And now that's the default theme. So now anytime we make any plot, it's gonna come out with that default theme. And so we can even like go to an example for geom point or something like that. And rather than having that gray background, now when we do this, we run this, that's our theme. We just created our custom theme. So we can just stick this my theme bit and this theme set thing. We can put these up at the top of our script and like comment it really well and talk about what all this stuff does, explain it all with comments, and then all your plots after that will come out looking the same way. So that's really useful. This is the yeah, let's see, we got some comments. Yeah, wow, what a game changer. I always rewrite everything for all the plots. Yeah, and then you have to go through and change all of them if you want something different. Right. And so this is a way that you can just have everything up at the very top of your script and you can tweak all your plots by just changing it in one place and not have to worry about changing it everywhere. And then you can even combine that, right? So you could have P1 plus my theme plus theme, and you can have some tweaks on top of that. So that totally works. You can have multiple theme calls there. So, yep, useful stuff. So this is what I ended up settling on for our theme. So I will not set it here. And I will actually use this one from the slides. But actually, no, I'll keep it in this document because this is stuff we worked on together. So yeah. So again, the theme is for changing things about like the appearance of the plot. And if we want to go back and change things about how data is mapped to the plot, which we often want to do, we do have to like go back up in our code and change things in the scales, the geoms, the aesthetic mappings, perhaps. This is the little tweaks that come at the end. Cool. Multi-panel figures. Okay. It is this easy. So there's a package called Patchwork. Oh yeah, Val, do you have a question before we move on?
Yeah, sorry, it just occurred to me. So if I use the my theme figure and do what Wesley just said, I have different figures that I all assign the theme to, but then maybe for one figure, I want the text to be at a 45-degree angle, but for another figure, I don't want that.
Yeah.
Would what I do specify in each figure override what I specified in my theme, or how does the hierarchy work there?
So let's see. So if we do just P1, let's just use P1 here. P1 plus my theme. We've got them at an angle. If I wanted to override it, I think I can just do axis.text.x text, maybe with no arguments. I don't know. Let's see what happens. Nope, that didn't do anything. But if we do angle equals 0, would be flat. Yeah, we can like put it back if we wanted to do that. In this case, probably the oops, I guess 0.5 is right in the middle. Now we can see what that HJust thing does a little bit better. So that was how we would overwrite it. Probably what I would do in your specific example is not have this line in the my theme, like do it opposite. So just have a simpler my theme. And then for the plots where you want to modify it, do it only to those plots because you're like adding additional arguments here. So yeah, you totally can have like a theme for everything and then apply that to a plot, but also apply some additional theming stuff. Yeah. Cool. So multi-panel figures with the patchwork package are super duper easy. You load the package. So before I load the package, if I try to add P1 plus P2, it'll give me an error. It'll tell me like you can't. Oh, I already loaded it. So if you didn't have it loaded, it would give you an error. But once you do have it loaded, that's your multi-panel figure. We've created. This is one thing, and it was that easy. So that is like the beginning of it. It's just the beginning though. We can be more specific about our control. We can use the plus to just kind of wrap plots, combine them all. If we want to be specific about how they're combined, this vertical bar combines plots horizontally. This / combines them vertically, one on top of the other. Think like a fraction, right? And you can use parentheses to nest these operations, just like algebra sort of, right? So here's an example where I've put P2 horizontally next to P3, and on top of both of those is P1. And I've expressed this in a very simple way here. I'm going to actually go down a little further here since we're doing something new. I've expressed those in a very simple way, and with this nice syntax here. So really cool. We can control the layout. We can also do my favorite thing, which is where we've got multiple plots that have the same legend. It's very easy to combine those with this plot layout function. So we've got in our bottom half of this plot, in these parentheses, I want to do P2. This could be a bar to specify that they're next to each other, or it could be the plus. That's fine. And then we add this plot layout function. We say guides equal collect. So first, I'll show you just this here. So P2 plus P3 gives us that. Oh yeah, they're on the bottom now because we're using my theme. And if we do guides equal collect, then we just have one legend for both of them on the bottom. This is usually what you want, right? You don't want to repeat legends in a multi-panel figure. There's another thing, which I'll take this moment to show you. You can use an ampersand to apply something to all the plots. So this would be useful, for example, if I wanted to go back to theme black and white and not use that default, I can do that like that. So that now applies theme _BW's regular ggplot function to both P2 and P3 at the same time. So this is another way to kind of do theming for all your plots or all your subplots. What key makes the line symbol? It's on my keyboard, it's right above the enter key. It's a backslash, so it's shift \, I guess, makes that pipe symbol. or a bar symbol. So yeah, we could do like that to show that they're side by side. We could put one on top of the other with a forward slash, like so. So we can also add the labels to those panels with the plot annotation function. So in this case, I've given it tag levels. You can give it an uppercase A or a lowercase a or a number, I think, a number 1, and it'll label them appropriately. And then tag, you can give it a prefix or a suffix. So in this case, I put, parentheses after it, but we could also put like parentheses both before and after with both of those things. So we could do something like, I think there's a, tag prefix equals begin parentheses, and let's make these capital letters, for example. What did I forget? Comma, forgot a comma. And then now we've got this plot. And oh, you know what? Let's beam black and white. Oh, that broke my guide. My guides equal collect. So I'll have to not have that theme set to make it look nice. I think we made a funky theme. So I could do the other way I could do it is just here, theme set theme BW. So let's change it back to a not custom one. And let's see what it looks like. Oh, error. Try it again. Oh, what's going on now? Theme set. Oh, do I have to do that? Yes. Okay. I'm just resetting it to defaults here. Now, for some reason, my plot layout thing is not working. Maybe that's why these were pluses before. Let's see. If I change that back to a plus, does it work? Yes. Okay. So apparently the plot layout doesn't work when you have two plots that are combined specifically horizontally, which is interesting. Did not know that. That might be a bug. So yeah, we can arrange these multi-panel figures very easily, I think. Very nice. So here we've got P1 on top, and then on the bottom, P2, P3, and our collect all our legends into one spot, add the annotations. That's it for multi-panel plots. Saving plots. So built into ggplot2, there's the ggsave function, which does not get used often enough. So, there's kind of two approaches to making a figure in terms of sizing it. So the problem with okay, it looks nice here, right? But this is particular to my window, right? If I click on that zoom button, we see that if I move this around, if I readjust this, there's certain sizes of this where it looks terrible, right? Like this is unreadable. The font's way too big. And if I expand this to fill the whole screen, well, the font's pretty small. It could be larger. And so I think that it's a good idea somewhat early on in your plot creation to start saving it out at a particular size and a particular resolution. If you know what the journal requires, that's even better. If not, you can kind of guess what it would be in inches on a printed page in a 2-column journal article, and you can save it out and see what it looks like. So we do that with this ggsave function. The first argument is the file name, and it figures out the file type based on the extension here. So if I wanted to save this out as a JPEG, I would call it penguins.jpg. If I wanted to save it out as a GIF, I would save it as penguins.gif. So in this case, it's PNG. The next argument is actually optional, which is kind of weird, but this is which plot to save. By default, it's whatever the last plot you looked at or that you ran in your code. But I think it's good practice to specify this. And then we've got arguments defining the dimensions and the resolution of the plot. So the width, the height, and the units together define the dimensions. So this is going to be 7 by 5 inches, but you could make it 7 by 5 centimeters or whatever. DPI is the resolution. So this only applies to raster images, and I'll talk about what a raster image is in a second. You can put in an actual number here, like 72, or you can put in, I think there's like print, retina, or something like that. There's different options here for kind of presets. And then this background argument is nice because by default, in PNG files, at least, the background is transparent. And so when I made this plot before and didn't specify background equals white, well, you could see the blue background of the slide through the plot, and it looked pretty bad. So I went back and changed it, background equals white. This is also where you can produce, high quality images for journal publications. So very often I will start with PNGs because they're small file size, and just use those, kind of check things out. And then once I've got things looking nice, I will make sure to save a high resolution version, as well as, if possible, a vector version. So what's a raster? What's a vector? Raster images, for example, JPEGs, PNGs, TIFFs, these are made of pixels, and the resolution can vary. And so here's, for example, a low resolution a raster image. And so if I kind of zoom in on it, like, you can see that it's blurry, and that's no good. And so let me zoom out here. And a vector image is not made of pixels. And so what's actually recorded in the file, for example, in SVG, PDFs sometimes are vector, EPS is another format that journals ask for a lot. These are not made of pixels. They are the actual file. You could like open it up in a code editor like R, and you could see like lines of code basically defining how to draw this thing. So they don't have a resolution. I can zoom into this infinitely, and you will never see pixelation happen because it's being drawn right there in my browser. Now, that's probably your best option. It doesn't matter a whole lot, the difference between a high resolution raster image and a vector image. For print, doesn't matter a whole lot. But for the web version of your article, it's nice to have that vector version of the graphic if you can supply that to the journal and they can use it. They might not always use it. They might convert it into a raster, who knows? But that is going to be the highest sort of quote unquote resolution that you can give them, even though there is no such thing as resolution for these. These are also more compatible with screen readers. So people who are visually impaired or use screen readers can get some information out of these plots because they are like accessible to screen readers to some extent, like they can read the text on them, whereas a raster image is not. So especially for web stuff, it's best to use something that's a vector format. So that kind of brings us to the end here. This is the whole thing, the finished product, all the way to, saving out the image. Oh, actually, I didn't include that, but we have it here. We have an example of how to save this out. And so this is everything that we did in the slides here today is here. So you could copy and paste this and run it and kind of reproduce everything. And that's what our finished product looks like. And I think it looks good enough for a first round of reviews, at least, right? There's a few more things that we might want to do. Like we might want to make these italics. The scientific names should probably be italics. For some reason, my modifications to this legend didn't make it into this version. So there's a few more things we could play around with for sure. But hopefully that gave you an idea. Wesley asked a question. How do you export it as a vector image? Yeah, easy. You just change this file type. So SVG is a common one. I think journals accept one, EPS. So if I just did penguins.eps, that would save it out as a vector image. PDFs are also saved as vector files. So we could save our, we could do ggsave done.pdf. Let's be a little more specific about where I save that. Let's save it to the desktop. Plot is P. Unexpected symbol. Oh, comma. Forgot a comma again. Yeah, so that's all we have to do. I'm not supplying any sizes there, so it's using this default of 4.78 by 2.7. I don't know why. And then we can find that and open it up and prove to ourselves that it is a vector image indeed. So here it is, and I can keep zooming in forever, and there's no pixels. So yeah, PDFs get saved as vector. And you can also see here, like I can highlight the text. And so this is how a screen reader is actually able to like read some of the information in this. You can also see that this size that I've chosen does not work with the point sizes I've chosen or the axis labels I've chosen. So this is why it's good early on to set the sizes to like what the journal might like. And then you can adjust your font size and your point size and your, stuff like that in accordance. And the options for the raster images, you asked about the options for resolution. We have DPI, so we can give it some words or numbers. So we could do retina, which is high enough that on a retina display, I guess you can't distinguish pixels, print, or screen. This would be like good enough for giving a talk or something like that to put in a PowerPoint, right? And it'll be a smaller file size if you do that. Or you can just put in whatever number you want. You could make it, I think you can do like 73 DPI if you want. These are just common resolutions, I think, that are used. Yeah. So I did want to point you to where to go to get more help. So the ggplot2 documentation that we looked at a little bit earlier is really great. There's a nice FAQ on customization on their site here with common things like how do I change the legend title? How do I, change the font sizes? So that's a good place to go. We also have this R graph gallery, which is really wonderful, has a lot of different types of plots with walkthroughs for ggplot2 of how to make them. So, how to make a basic one, how to control the color, and how to make an interactive plot heat map, for example. And these all have code along with them. So that's a great place to go. The ggplot2 book, if you want to really learn more about like the details about all this stuff, this is a great place to go. It also has things about annotations, which I know somebody asked about in the beginning, and arranging plots with I think with patchwork also. Yep. And then we have our drop-in hours on tomorrow is our next one, tomorrow morning, and I'll put a link to that. And so if you want to come to our drop-in hours, they're every Tuesday from 9 to 10. There's a link to our wonderful little space here that you can join and chat with us, with each other, to get help on that, help with ggplot2 or other things related to R or data science. And then, yeah, next week, I'm sorry, it's not next week, it's the week after next. It's June 26th is the third part of this that Christina and I will be co-teaching, where we're going to be looking at a variety of extensions to the ggplot2 package. Yeah, we haven't totally decided on what extensions we are going to do. So this is where if you want to have a particular package in mind or a particular cool thing, like, is there a ggplot2 package to help me make some particular kind of plot for RNA-seq analysis, right? We can look for that, and we can try to include that in this workshop if that would be helpful. So yeah, that's all I've got. And thank you all for coming, and hope you learned some stuff.